Hi students, welcome back. We're going to graph another standard function, f of x equals 1 over x. This one will need a few more points. We've been getting by with 3 points so far, and let's do a few more because the behavior of this function, when we let x be a value that's pretty large, well, what's going to happen is that that function, because it's 1 over that x, it's going to get very, very small. So to see a good behavior of this, to see what it looks like, let's really make sure to choose several values of x that are going to help us. Let me start with 0. Now, what's the problem here? 1 over 0, 1 divided by 0, 1 divided by 0. That's not going to work too well because there's nothing that when I multiply it by 0, I get 1. Never, it can't happen. So this is undefined, which is interesting. That means that this function will never cross the y-axis because it's not defined if x is 0, which is any value of y here, or f of x, x is 0. Like this ordered pair right here is 0, 1. This one down here is 0, negative 2. It's never going to cross that axis. Let's choose a value of x like 1. So if x is 1, I have 1 divided by 1. That's okay. That's just equal to 1. So our ordered pair, 1, 1. And there it is. If x is 2, we'll have 1 divided by 2. Well, that's 1/2. You could also think of it as 0.5 if it helps you to graph with decimals. So x is 2, f of x is 1/2. I'm going to keep it in fractions, but you could definitely use decimals, not a problem. X is 2, f of x is 1/2. Right there. X is 3, f of x is 1/3. Now this one would be a little bit harder because 1/3 is 0.3 with that overbar. The 3 never ends. It's a repeating digit. So once again, I'm going to write this as 3, 1/3. It's not too hard to graph fractions like 1/2, 1/3, 1/4. So x is 3, and I want to go up about 1/3 of the way between 0 and 1 here. So I think you can start to see what's happening. It's interesting. But we don't see the whole picture yet. We have to choose a value between 0 and 1. Let's choose 1/2. Let's let x be equal to 1/2. And then what do we have here? 1 divided by 1/2. Well, do you remember how to divide fractions? You have to take the numerator, which is 1, or you could think of it as 1 over 1. And you're going to multiply by the reciprocal of the denominator. So you'll have 1 over 1 times the reciprocal of 1/2, which is 2 over 1, or 2. And this is going to be equal to 2. So our ordered pair, if x is 1/2, our f of x is 2. So 1/2 would be right between 0 and 1, about right there. And then notice how high f of x or y is. We're starting to see this cup here happen, this curve. As we choose smaller values for x that are between 0 and 1/2, like 1/4, let's just do one more. We'll have 1 divided by 1/4, and that will be equal to 4 because it'll be 1 over 1 times 4 over 1. So as x is getting smaller, our f of x is growing. 1/4 would be about right there, and that would be the height of that point. So we can graph this part of the graph. We can connect the dots now in the nice curve that we have. But we're not done because we didn't choose any negative values. So let's go ahead and choose those negative values and see what happens. So let's choose some negative values for x. really the same values, positive values that we had over here. We'll just choose the same ones for the negative side. So if x is negative 1, f of x is going to be 1 over negative 1, which is negative 1. Our ordered pair will be negative 1, negative 1. If x is negative 2, we'll have 1 over negative 2. Remember that with a fraction, when we have 1 over negative 2, that's the same thing as negative 1 over 2, which is the same thing as the whole fraction being negative. If the denominator is negative, the numerator is negative, it means the whole fraction is negative. So this is negative 1/2. If x is negative 2, f of x negative 1/2. Same goes for if x is negative 3, we'll have 1 over negative 3, which is negative 1/3. X is negative 3, and f of x is negative 1/3. If x is negative 1/2, we'll have 1 divided by negative 1/2. So let's write this to make it easier as 1 over 1. We can express this 1 as 1 over 1 divided by negative 1/2. So we'll take 1 over 1 times the 1 over 1 times the reciprocal of negative 1/2 to, that's the way we divide fractions, which will be negative 2 over 1. So this will be negative 2. And our ordered pair would be negative 1/2, negative 2. And then finally, let's let x be negative 1/4. We'll have 1 over negative 1/4. And in a similar fashion, we'll end up with negative 4 because we'll take 1 over 1 divided by negative 1/4 or multiplied by its reciprocal, and we'll end up with negative 4. Our ordered pair would be negative 1/4, negative 4. Let's go ahead and graph these. So negative 1 puts us in quadrant 3. X is negative 1, f of x is negative 1. X is negative 2, f of x is negative 1/2. So now I want to look at where is negative 1/2 on the f of x or the y-axis, and it's right there. So that ordered pair would be right here. If x is negative 3, f of x is negative 1/3. So I'm going to get closer. I'm getting closer and closer and closer to my x-axis, which is actually acting like an asymptote. You might remember that from a previous algebra class. So it's acting like basically a ceiling here, that this graph is going to grow on this side, get higher and higher in terms of y or f of x, but it's never going to cross that axis. If x is negative 1/2, so right here is x equals negative 1/2, then f of x is negative 2, x is negative 1/2, f of x negative 2. And then if x is negative 1/4, right there, f of x is negative 4. So down here. Connecting the dots in the curve. Interesting function. You can see that it has two halves to it, this upper half and this lower half, upper half in quadrant 1 and the lower half in quadrant 3, but it's never ever going to cross the y-axis, and it's never going to cross or intersect with the x-axis either. So both axes are actually asymptotes. We call the x-axis a horizontal asymptote. We call the y-axis a vertical asymptote. I hope that helps you, and I'll be seeing you soon.